Hello, my name is Salma Farhat. I'm working on safe dynamic reconfiguration of concurrent component-based applications with Simon Bluzzi and Laurence Duchien. In the context of cloud applications, a system configuration is the set of resources that host an application, as well as a set of rules that define the coordination and the dependencies of the system subparts. In such environments, systems should be capable of adapting at runtime to remain compliant to new user demands and environmental constraints, since initial configuration is only meant to meet startup system needs. Thus, this calls for extending the life cycle of software systems by a reconfiguration step to go beyond analysis, design, development, and deployment. To this end, our goal is to be able to manage the reconfiguration of concurrent component-based applications while minimizing the computational overhead at runtime by avoiding computing the possible configurations at neither the design time nor runtime. And we also aim at providing the means to request reconfigurations safely without requiring the user to compute the valid reconfiguration path. So how to achieve our goals? Our main objective is to define a component-based runtime variability model, encoding the semantics of a feature model, to control reconfiguration operations while ensuring that only valid configurations can be selected as a result of any reconfiguration request. A valid configuration is a set of features that satisfies all the constraints of a feature model. We leverage feature model to model the variability of a specific domain in terms of features and their relationships, so that we can encode the semantics of this feature model in the generation of the JavaBIP model, the variability runtime model. The components of the model are at the right hand side, are generated based on the nature of the feature, and the coordination layer that defines the dependencies between system subparts is generated based on the hierarchical and integrity constraints of the feature model. The generated model will be running alongside the application. It will be used to monitor and control the application. It will intercept reconfiguration requests as shown in the bottom level here, and execute reconfiguration requests by calling corresponding applications API while ensuring by constructions the safe behavior of the application. As an example of how the model controls the application, assume that the user wants to activate the camera feature. As shown in the feature model, camera feature requires high resolution. This means that camera feature can only be active if high resolution feature is already active in the configuration. This constraint will be transformed as highlighted in green. The synchronization of the camera transition in the camera component with the high resolution to high resolution transition in the screen component, which this enforces screen component to be in high resolution state in order to activate the camera feature. We measure the overhead of the model in terms of time. We generate random feature models up to 500 features as shown, and Z corresponds to the number of the components generated for this feature model. The overhead is proven to be negligible in order of milliseconds, and this is due to ensure safety properties by construction. We found very few references in the state of art that mentions performance, and those ones speak in terms of hundreds of milliseconds. Thus, our sub-milliseconds overhead is very good. In conclusion, we worked on enforcing by construction the safe behavior of concurrent component-based systems. We also worked on minimizing the overhead imposed on the application while applying reconfiguration. We are working on extending feature models with time and temporal constraints, since the feature models that are currently supported in our work cannot fully represent cloud-like platforms. Thank you for listening.